So we know the farther away the alternative from the null, more power. Right? Bigger sample size, more power. Check the first two. The same sample size. Which one gives you more power? The sample size is the same, has no impact. Alright? So same sample size. The alternative. This is closer to this than this. This is more power. Because the alternative is far away from the null, right to that one, right? So this is not correct as a result. Comparing A and B, I can eliminate A. Then I can compare which one? I can compare B and T. The same alternative, bigger sample size, more power. That allow me to eliminate this one. Alright? So I end up with C, D, and E. Then I can go to C and D. This is farther away alternative, more power. The sample size is the same. And I have D and E. Bigger sample size, more power. Farther alternative, more power. So on both fronts, this gives me more power. That's the answer. Even if this was say 0.85, this is 58, I would have still said D will give more power because the sample size is 6 times more. The alternative is not much difference, right? But in this case, it's obvious. D on both fronts give me more power. Bigger sample size, farther away alternative. But even if one is like, even if you flip it, make the alternative closer, this is 0.5 closer, this is like 6 times more. So more likely the sample size will dominate, right? But in this case, it's sort of obvious. You have the answer on both sides. As a result, D will give us more power in this case. I use a simple rule of thumb. Bigger sample size, farther away alternative. More power. That allows me to eliminate all but D. Right? Okay. Part B of this question asks me to actually find the beta. The sample size is given as 64. The alternative is 56. So the question says two population mean is 56. Doesn't say alternative 56. But if you read the two population mean, it's in line with the alternative. This is the alternative. It doesn't say alternative, it doesn't have to say it. It says the two population mean is 56, which basically means the alternative is correct. Yep. Too small? Is that good enough? So by saying two population mean is 56, it's telling you the alternative is correct at 56. Right? So don't check for where is the alternative, right? It's right there. In the statement must not be stated as you wish. Alpha is 2.5%, and the rest were given in the question. Sigma was 12, and step number 1, which is setting the hypothesis, is already given. So step number 2, I need to find critical value on the original distribution. Alright? That's a null. Minus or plus Z of alpha? Is it minus Z of alpha or plus? The lower tail test. Minus. The lower tail test. Minus Z of 2.5%, 1.96. Standard error, which is fixed one. That give me critical value of original distribution. And upper tail test, this is a plus, and the lower tail test is a negative. The rest is the same. What do you get there? What would be X bar star? What's the X bar star? $56? 57 point?
06.
02. 02?
06.
So this is 57.06. The alternative is less. The alternative is 56, so I'm going to graph it in accordance. We can calculate two areas. This is one. This is two. When we calculate zeta beta, we can calculate both of these two areas. So when we do step number 3, which is zeta beta, that should allow us to calculate both of them. Let's calculate zeta beta, see which one we need. What is zeta beta? What is zeta beta? Here's a positive number. How much do you get? 1 pound? 1 pound? Not 1 pound. 0.63?
71.
0.71? That's 0.71. That zeta beta allows you to calculate either of these two depending on the case. The case asks you to find the power. Which one's the power, which one's the beta? One of these two is the power, one is beta. Which one's the power? Toward the test, that's a power. Opposite, that's a beta. So that is power. That's toward the test. That's what you're trying to find. In step number 4, which is the power, you need to find that area. The power is probability that Z is less than 0.71. Alright? That is the power. So Z is positive, you try to find the probability of less, you add to whatever you get from the table for 0.71. Z is positive, you try to find the probability of less. Alright, the rule of thumb is check the table, find 0.71, add 0.5 to it. Alright? So check the table. 0.71. What do you get from 0.71? 2611, right? 2611?
Yeah.
I look like 2611. This is 76, 11%. Right? That is your power. The beta would have been probability that Z is more than this one, which would have been 0.5 minus 2611, which would have been around 33%, which would have been this one. So the answer should have been none of the above, but some people answered C on that test, which we gave them the marks to. Right?
Wouldn't beta be 23%?
Beta would be?
Close to
24%, so we're fine, none of them were even close. The answer was none of the above. This is how much? 34%?
23.9.
Why? It's 0.5 minus 26.
Oh, yeah, still.
So you get 20? Yeah, 20. 23.9, yeah. So none of them were close. The answer would have been none of the above. Normally I don't put it so close. Right? My 10. 20, 23, yes. 8, 9%, right?
Yeah.
So the answer would have been none of the above. Normally I put none of the above in case I made a calculation. Right? Normally it's not intentional. It's not like the answer is none of the above. So in that year probably I made a calculation or something, right? Make sense? I put the number for it. But the answer would have been 7611, right? And none of them is 7611. Alright? Yes. Anyway, just a note. If you solve it, Normally you don't find both of them. You don't find beta and power together as an answer because some people go all the way to the end and mix up these two. I don't put both of them, alright? I put one, the other one is off by a couple of percentage, right? That's what I do normally. So if you solve it and you don't find the number there, most likely you have it wrong. Alright? Or 1 in 100 times happened that I was wrong. I put none of the above for it, right? Somehow I missed it, right? Calculation was somehow I missed it. Although I use a computer for it. Somehow I missed, right? So I put none of the above for it. Never none of that is intentional. So if you solve it, if you get it, couple percentage off, most likely you're mixing it up. Alright, most likely basically find the beta where the answer is power or the other way around. Alright? Make sense? Anyway. That is this next one. Has nothing to do with the power calculation, just the issue of proportion. I want to see if you understand the concept. We'll come back to beta soon. You got 97.5% confidence interval for the proportion. That's what you got for it. That is 97.5% confidence interval for the population proportion. That's what the question is saying, right? Based on it, which statement is correct? Number one said, it's reasonable to say that less than 19.5% dine outside. Is it reasonable to say this one? Can you say this one reasonably or not? Can you say that one? Based on that confidence interval. Can you reasonably say this? That's what the question said. It said it is. To say this one, you should reject this one. Can you reject that one? You can't. You got 19.5 fall inside. You cannot reject it. So based on that confidence interval, knowing that 19.5% fall inside, this is reasonable to say. This is not. You cannot reject the no. So if you cannot reject the no, no will be reasonable to say. The alternative will be not reasonable to say. Make sense? Okay, so that is not correct. You cannot reasonably say this because that's the alternative of that test. And to get it, you need to reject the no, and you cannot reject the no. Alright? Make sense? That's number one. What about number two? Is it reasonable to say this one? So the second one gives you the no. There's no less, there's no more. So no. It gives you a statement for the no. Is it reasonable to say this one? Yes or no?
Yeah.
Yes. This falls inside. You cannot reject it. So it's reasonable to say it. Anything within the range is reasonable to say. Anything within the range. You can say, I think 16% down outside, 19%, 20, anything within the range you cannot reject. So anything within the range will be reasonable to say. I gave you a number, but anything within the range is reasonable to say. Make sense? The problem with this one was the less. That's not the no, that's the alternative. To get this alternative, you have to reject this no, which you can't. Make sense? So that is correct. What about the next one? The next question says, the hypothesis that has this hypothesis, this no, can be rejected at 4%. True or false? This 20% falls inside the range. What does that mean? Well, it means you cannot reject at 2.5%. If you cannot reject at 2.5%, can you reject at 4%? If someone told you this test cannot be rejected at 2.5%, what about 4%?
Maybe.
Can you say it?
You can't say.
Let me grab it for you. This is, say, an upper tail test. This is 2.5% area. This is 4% area. This is 2.5%. That's 2.5%. This is 4%. If someone told you you're not going to fall in the 2.5% area, can you conclude about 4%? You don't know. If you don't fall in this, you're to the left of it. How do you know how far to the left you are? You might be there, you might be there. So, if you don't reject it an alpha, anything more you cannot say it. If you reject an alpha, well, let me give you a rule of thumb. Simple rule of thumb. Reject at alpha, reject at anything more. That's what you know. That's the definite conclusion. If you reject an alpha, you're going to reject at anything more. So if someone told you to reject at 5%, you're going to reject at 10%, 15%. Anything less, you cannot say it. Anything less, you cannot say it. Less, cannot say it. That's one way of having it. The other way of having it is this. If you do not reject an alpha, you do not reject when? At anything less. If you do not reject at 5%, you won't reject at 1% either. But anything more, cannot say. Make sense? Use that rule of thumb and answer this question. This question tells you don't reject at 2.5% because this falls inside 97.5%. If you don't reject at 2.5%, you know you're not going to reject at anything less, but anything more you cannot say it. You cannot say it. Not conclusive. Make sense? This is not true. It's not conclusive. You don't know it. You may reject it, you may not. You cannot answer it. Right? Makes sense? So, graph it. The graph will talk. You can figure it out, but that's the rule of thumb. If you reject an alpha, you reject at anything more, anything less, you cannot say it. If you do not reject at an alpha, you do not reject at anything less, anything more, you cannot say it. That's the rule of thumb. Okay. What about the last one? 26% falls outside. You reject at what percentage? 2.5. If you reject at 2.5, do you reject at 5%? If you reject at an alpha, you will reject at anything more. That is correct. So the third and fourth are using the rule of thumb I gave you. If you reject at an alpha, you're going to reject at anything more, anything less you cannot say. If you cannot reject at an alpha, you cannot reject at anything less, anything more, you cannot say it. Based on that, you should figure out this. Make sense? Okay. Anyway, that's a nice question. Remember it. It will show up at some point somewhere. Going back to calculation of beta. A normal population has a standard deviation of sigma of 9.8. So we have sigma at 9.8. The sample size is 50. The true population proportion is 44. That is your alternative. So when it says true population mean is this, if it's in line with the alternative, it's basically giving you the alternative. The alternative is 44. You're doing the test at 10%. What would be the power of this test? That is what the question asks you to do. Calculate the power for that alternative. So most often it doesn't tell you alternative. It says the actual population mean or later on proportion is this. If you check it and it's in line with the alternative, that's the alternative. All right? The test is already set, so I'm going to calculate critical value on the original distribution, which is the null, plus, because that's upper tail test, z of alpha. What is z of 10%? 1.28. Standard error, which is this one. What is critical value on the original distribution? Let me graph it for you. You're trying to find a number here for which this area is 10%. That is your no. What do you get? What is x bar star? What's your critical value on the original distribution? It's obviously more than 40. What do you get?
41.8.
41.8. This is 41.8. The alternative is 44. I don't have space, but you can see to the right of 41. So when you graph it, it's to the right of this one. So graph it in accordance. I don't have space there, but you can see what I'm doing. Now, if you go to step number 3, I call this step number 2 already. If you go to step number 3, calculate zeta beta, which is this one. That should allow you to calculate these two areas, depending on what you're interested in finding. That's 1, that's 2. Now we want a power. Which one we want? Which is the power, which is the beta? That's the beta allow you to calculate both those areas. The blue area and the black one. Which one we try to find here when the question says find power? Yeah?
Blue.
Blue is when you don't reject a null. The black is when you do reject a null. Towards the test, that's the power. Opposite, that's the beta. Right? So be careful with it. That mix up is very common, right? In a multiple choice, you may miss the whole thing. In a long question, it's small deduction, but be careful with it.
So the test is 41.8 in this case.
An
right?
upper tail test. Upper tail more is a power. That's when you reject the null. You don't commit after her, right? Lower, opposite. That's when you don't reject. That's the beta, right? So the power's probability that z is more than z of beta. What is z of beta there? What is z of beta?
1.59.
1.59.
It's minus.
59? Okay. So remember, this z of beta can be anything. I've seen people trying to form expectation. Say upper tail should be this, lower tail, no relation. It can be positive or negative for either one. Alright, it just says that. Make sense? So don't form expectation. So go to the null table, try to find that probability. Z is positive. You try to find the probability of more, you subtract from 0.5. That was the rule of thumb, right? Make sense? 0.5.
But it's minus, right? Minus 1.59.
Is it minus?
Yeah.
Oh, that's minus. I thought it's positive. Minus. My mistake. Z is negative. You try to find a probability of more, you add to 0.5, whatever you get from the table. Right? I thought positive for some reason. Negative. Minus 1.59, ignore the sign, look at what 1.59, add to 0.5, whatever the table gives you. So let's go to the table, 1.59. 1.59. That is 4,319. Is it? 4,319. Am I right? 4,319. Huh? Is it 149 or not?
No, it's the row below that.
Right. 159. I'm reading 149 for some reason. 159. 444. Yeah, 341. For that alternative, this does have good power. Good power. That's the alternative. You reject the null, make a correct decision. Alright? Good power means for that opening, you will reject the null and make a correct decision as well, as a result. Mark? Yep. The power is like confidence, right? Normally, nani is for what it is, right? Treat it like confidence, treat the beta like alpha. Right? If that's the ultimate interest, you want the power to be 90% enough. Right? You don't want the power to be small. Make sense? Okay. So that's sort of like good test, good power for that whole thing. But I treat the power like confidence, alpha like beta. You don't want alpha to be more than 10%, you don't want the beta to be more than 10%. The confidence at least 90%, the power at least 90%. Okay. Okay, next one. Sort of the same test. Let's do it fast enough. Lower tail test, not upper tail. Step number 2, calculate the critical value on the original distribution, which should be 30 minus, not plus, minus z of alpha. What's the alpha? What? 1%. What is that 1%? 2.33. Sigma. Sigma is 80. That's variance. 80. N is 500. See, in this question, I gave you sample mean. Sample mean is useless, right? The power is calculated before you take the sample. If you have a sample, the sample is irrelevant to it. This is just there, it doesn't do anything. So X bar is never used. The actual X bar is never used in the calculation of power. This is there to see if you use it or not. This is useless. Now I give you S, 75. Do you use that one? You don't use that either because you have sigma. Make sense? Since you have sigma, S becomes useless too. So this is useless as well. I didn't use the sample at all, just sample size. Right? The actual sample is irrelevant to the calculation of the data. What do you get there? What is our critical value on the original distribution? How much? What's the critical value on the original distribution? What's that number?
21.66.
21.67?
66.
66. Now calculate zero beta, which is 21.66 standardized by the alternative. Now that should allow you to calculate two areas you can calculate either this area or this area. We want the beta. Which one is the beta? Is it more or less? Which one is beta? The red one or black one? Black one. Opposite. That's the beta, that's when you don't reject. Towards, that's the power. So I need to calculate probability. Is that more than what you found here? What did you find there? What is that number? It's positive, I guess. It looks like positive. What do you get? What is that number?
0.18.
1.8? That is the beta. So Z is positive, I want to find a probability. The more I subtract from 0.5, whatever I get from 0.18 on the table. Alright? That is the beta. 0.18. Let's go to the table. 0.18. Where is 0.18? 18. 0.0714, right? 0.0714. 714. That's the beta. Probability of more. That should be 42.5. 8, 6%. Lots of error there. That's the alternative. You're gonna make an error, right? You're not gonna reject it all and make an error. Right? Make sense? Okay. As I said, we don't do two-sided test. Upper tail, lower tail, just follow the rules. Right? Test-wise, for some reason, people don't do the calculation of data. When I say that, I mean just a calculation, right? Even if you don't know the concept, you should be able to go through the process, right? And you will get an average of 50%, sometimes even lower on it, right? For a question like this. Okay, one more. We are doing a test. The null is given. That's a null. The alternative is given. That's 35. Sigma is given. That's 14. Alpha is given. That is 10%. We want the power of the test to be at least 99%. Choose a sample size large enough to achieve. If the power is at least 99%, what would be the beta at most? With the power of 99%, what would be beta? 1%. The beta would be 1%. So the question basically tells you find the sample size such that the beta is at most 1%. That's what the question says. Alright? Apply the formula. This is the formula. What is Z of 10%? 1.28. What is it of 1%? 2.33. As I said, if you have doubt, just look at the last row of t-table. That's squared. And sigma is 14 squared. Alright? Make sense? Apply the formula. This is the distance between the null and the alternative, which is 5. This is 40. This is 35. That's 5. This is 5 squared. What do you get? I apply the formula. Z of beta is 2.33. Z of alpha is 1.28. That is 14 squared. The distance between null and the alternative is 5. What do you get? What number do you get there? What is the number that you got there? Give me the actual number. 100, 200, how much? Don't round it yet. How much? You round it. Without rounding, how much do you get?
102.17.
So you always round up. So you should have at least a sample size of 103. If you want the power to be at least 99, i.e. the beta to be at most 1%. Alright? Make sense? That's lower tail. See, I ignore the lower tail nature of the test. So Z alpha and Z beta are absolute values. The direction of the test doesn't matter. Alright? Okay? Okay. Okay, that is this one. I'm gonna start one. We'll do some of it next week, more of it. We did everything for the mean, not for proportion. I'll give you an example of proportion, show you the difference, tiny difference, right? Tiny difference. So let's see what we have here. We want to test if percentage has increased over a historical number of 25%. Read the question. That is the test. The employees, 25% were female historically. We want to see if it has gone up, an upper tail test, right? We want to do the test at 5%. The sample size is 186, right? What would be power? What would be power? If the actual population proportion is 28, i.e. if the alternative is correct at 28. Make sense? So it looks the same, it's just different parameter. What should we do? An upper tail test, alternative is given at 28%, which is in line with the alternative. What was step number 2 in the process? Calculation of the critical value and original distribution. For the mean, look like this, right? We did it this way. It was the null plus upper delta Z alpha, this. For the proportion, it becomes the null plus Z alpha. We need the standard error. Where do you get the standard error from? We use the null. So for the standard error, we use the null. Make sense? Okay. Let's apply and see what we get here. That's 25. Z of 5% is 1.645. That is 25. That is 1 minus 25. That is 186. What is that number? I want this number. How much is it? That's the critical value on the original distribution, but for the proportion, which shouldn't really matter. What do you get?
0.3.
How much?
0.3.
Exactly?
It was like 0.302.
Okay, 0.302. Now, this is 0.302. The alternative is 28. I want to find a power. I can find these two areas using Z of beta, which is the next step. This is one. There's another one. We can find both areas. One will be beta, one will be power. Either way, we have to calculate Z of beta as before. We have to calculate Z of beta. Take this one, standardized by the alternative. The difference is here. For the mean, you have a sigma. Use it in both places, right? For the proportion, there is no sigma. The standard depends on the population proportion. Up there, I use the null. Here, I should use the alternative. Initially, assume the null is correct. That gives you the critical value. Then you assume the alternative is correct to get the beta. All right, so you should use it in accordance. This is 28. Don't put 25. If you put 25, that gives you a wrong number. This is the only difference. The only difference is there is no sigma. The standard depends on the population proportion. So when you find the critical value, use the null. When you find the Z of beta, use the alternative. That's the only difference. The rest is the same. So what do you get for Z of beta? What is this number? It will be positive, I guess. What would be the number?
0.67.
167. So which one I want? I want a power. Which one is the power? Is it more or less? I want a power. Which one is the power? The blue or the black? The power is what you reject for the test. The beta is when you don't reject. Opposite, this is the power. That's the beta, right? So the power will be probability Z is more than what you found. Probability Z more than that one. That's the power. Right? Which should be 0.5 minus whatever you get from the table, because Z is positive. I want to find a probability more. I subtract from 0.5. Right? Okay, that is that. Go to the normal table, find 0.67. Where is it? 2486, right? 2486. 2486. That is 25.14. If you would have calculated the opposite, that would have been beta, which would have been 0.5 plus 2486, which would have been 74.86%. But the question actually calculates this one. I've seen a mix-up often on which one is which, right? On the long question, you get obviously a good chunk of the question right. On the multiplication, you get the whole thing wrong. Fortunately for you, I don't put both of them there. If this was a test, I would have put the correct one. This probably would have been 78, 79%, or 70%. I would not have given you the complement. All right? Yep.
So how would you indicate whether it's greater than or less than? How did you
Toward the test. That's the power. Opposite. That's the beta. So I want to find probability of more, not less. Toward is more than upper tail. Make sense? So check the test, upper lower tail, toward the test. That's the power, opposite, that's the beta. Alright, so in upper tail test, the probability of more than zeta beta, that's the power. Less beta. In lower tail test, the other way around. Make sense? So the rule of thumb is this, let me write it. Upper tail test. Probability of z is more than zeta beta, that is power. Probability of less, that is beta. Alright? That is upper tail test. In the lower tail test, is the opposite. Probability of z is less than zeta beta, that is the power. And probability of more, that is beta. Odd person don't memorize it, right? Why do you memorize so much stuff? Toward the test, that's the power. Opposite, that's the beta. That's easier than just trying to memorize. If you memorize it and then mix up at some point in time, right? That creates the problem. Anyway, we're done. You have quiz number 2. Just a note, take the quizzes as sort of learning by doing. Try to do it. Try to do it, spend time. And then pick up your test. If you've done it properly, that's fine. If you haven't done it, fix it. Yep.
You know, for sometimes the power, you add 5.5.
Then the next question becomes how to use the table. Then you go back to the original case. If that is positive, you want to find a probability, the more you subtract from 0.5. If you want to find a probability, you add to 0.5. If that is negative, the opposite. That's using the table. Make sense?